Okay, question number 4. We've got a car and a trailer moving along a road, connected. There'll be tension if it's going this way, and tension there. We're told the resistance to motion of the car is 200 plus lambda v. Resistance to motion of the trailer is 200, and we know the mass is weight. That one is 150, and the mass is the weight is 150 g, and the mass is 150, and similarly this is 600 g, and there's some sort of driving force here. Okay, so that's our scenario. Now we're going to use power equals FV. So we know the power is 15,000. We know the point we're interested in is when the velocity is 25. So that gives F is 600. Okay, now we're looking at using F equals MA, and we're going to do the whole system. So we're doing a car and a trailer together, because that will cancel out the T's. I could do two simultaneous equations, but if I do the whole lot, then the T's will disappear from my calculation. So I've got force forward, take away force back, take away the other force back, let's take away the two resistant forces, equals the mass, and we're told it's going at constant speed, so no acceleration. So I get, I know F is 600, 600, take away 200, take away 200, so it's 200, take away lambda v, and we know v is 25, and that equals 0, so that gives me lambda is 8. Okay, later on, now we're going up a slope. So now I'm going to draw a angled slope, angle theta. Similar diagram, just turning the page on its side in effect. This time I've got $600G, and this will be 600 G sine theta, and this will be 150 G, and the motion down the road, this is 150 G, and this will be 150 G sine theta, and we know that sine theta is 1/15. Okay, so this is 10 G, and 15, this is 40 G. Okay, so what are we doing now? So now we're doing power equals FV, still 15,000. The velocity at this instant is 10. So at that moment, F equals 1,500. Okay, driving force up the road. I've still got the two tensions. I've still got the resistance. And I'll put this 200 plus 8V, because we know lambda is 8 in the first part. As it breaks, we've got F equals MA, so 1500 is the force up, take away the weight of the component down the slope, so it's 40 G, take away 208, oh sorry, this is 8 lambda, this is V is 10, so that's 80, so that's 280. Should have filled that in. Rather than 8V, it'd be better to write 280, to be honest. 200 plus 80 equals mass times acceleration, and that gives acceleration as 1.38 meters per second squared. And now we've got to use the work energy principle, it's a long question as well, to find the value of D, okay, when it comes to rest. Okay, so now this is broken, so this is moving up on its own. So let's do a separate page. So we've got a straight line, we've got theta, we've got distance D, we've got a height change of D sine theta. Okay, and we're going to take the base as h is 0. So energy at the start, I put A and B. Energy at A, we've got a half mass times velocity squared, and we've got no gravitational potential energy. We've got work done against friction, is going to be FD, which equals 200 constant friction times the distance it travels, and we've got energy at B is mgh. Okay, and I know now for that this, the energy at A, take away work done against friction equals energy at B, or that equals that plus that. Doesn't matter how I lay it out. So this is 7500 equals, we're going to divide this by 15, so it's 10 GD plus 200 D. So energy at the start equals energy at the end plus any work done against friction. Okay, and then I get 7500 is D times 10G plus 200, and that gives me D equals 25.2 meters.